Dear students, welcome to Mathematics Online classes. We are solving exercise 10.2. In that, problem number 15 now. It says, find the position vector of a point R which divides the line joining two points P and Q. See, here is P, here is Q. There is a point R which is dividing the line segment. Position vectors of point P and point Q is given to us. Position vector of point P, OP is I plus 2j minus k, and the position vector of point Q is minus I plus j plus k in the ratio 2:1. So, here m is to n is 2:1. We need to find out position vector of point R when R divides it internally and also externally. First case we consider, that is internally. When R divides PQ internally, what is the formula to be used? Formula is, that is position vector of point R is equal to, what is that, how you write, m into position vector of the second point Q minus n into position vector of the first point P, this is OP, divided by m plus n. See, plus or minus you should not get confused. When it is internal division, plus, when it divides externally, minus comes. Very simple. M is 2, OQ is what? OQ is position vector of second point. It is directly given to us. Here it is minus I plus j plus k plus of n is 1 into OP is I plus 2j minus k divided by m plus n is 2 plus 1. Okay. Now, we will multiply this 2 with all three components, minus 2i plus 2j plus 2k plus I plus 2j minus k, 2 plus 1 is 3. This is equal to, now here you see minus 2i plus I is minus I, 2j plus 2j 4j, 2k minus k is plus k whole divided by 3. What is this? This is a position vector of a point R when it divides PQ internally in the ratio 2:1. We can write one more step here. This 3 will get divided to all three components. This will be minus 1 by 3 into I cap, 4 by 3 into j cap, 1 by 3 into k cap. Okay, fine. Now, coming to the external division, I will erase this. Second case, when R divides PQ externally, what is the position vector of the point R? Position vector of point R is equal to m into position vector of second point minus n into position vector of first point divided by m minus n, like this. Now substitute, m is 2, OQ is what? OQ is position vector of the second point. It is given as minus I plus j plus k minus of n is 1, OP is I plus 2j minus k divided by m minus n, means 2 minus 1. 2 will get multiplied with this, minus 2i plus 2j plus 2k, and this minus get multiplied to all the terms, minus I minus 2j minus plus divided by 1 it is. Okay. Minus 2i minus I is minus 3i plus 2j minus 2j 0, leave this part, plus 2k plus k is plus 3k. This is what? This is the position vector of a point R when R divides PQ externally in the ratio 2:1. This is about problem number 15. Now, we will take problem number 16. 16 is find the position vector of the midpoint of the vector joining midpoint of the vector joining the points P of 2, 3, 4 and Q of 4, 1, minus 2. 4, 1, minus 2. Here you need to find out a position vector of midpoint of a vector joining P and Q. P coordinates are given to us, that is 2, 3, 4 and Q coordinates are also given to us 4, 1, minus 2. With that coordinates, what I can write? I can write the position vectors of these points, and then they are asking you to find out position vector of midpoint. Midpoint will be somewhere here, internal division it is. That means whatever the length of PR is there, same length will be there with the RQ also. What happens to the m by n here? M by n will be 1 by 1. So, m is to n is equal to 1 is to 1. Very simple it is. Here we will write the position vectors of these 2 points. What is the position vector of the point P? Point P is 2, 3, 4 coordinates. So, vector will be 2i plus 3j plus 4k, and then vector OQ is 4i plus j minus 2k, that is vector OQ. Then position vector of midpoint will be position vector of midpoint of PQ is nothing but what? We know the formula as vector A plus vector B divided by 2. What is vector A? Vector A is position vector of the first point, vector B is position vector of second point divided by 2. In the same way, here position vector of first point means OP is there. Here we have vector OP plus vector OQ divided by 2. Write these two. Vector OP you write. It is given as 2i plus 3j plus 4k plus of vector OQ is 4i plus j minus 2k. 4i plus j minus 2k whole divided by 2. 2i plus 4i is 6i, 3j plus j 4j, 4k minus 2k is plus 2k whole divided by 2. Shall we take 2 common from the numerator? Yes, 2 is common, take it out. 2 into this is 3i plus 2j plus k whole divided by 2. 2 get cancels out. We have here 3i plus 2j plus k as the position vector of a midpoint of a point joining the what is that? Position vector of a midpoint of a line joining the points P and Q. Now we will take the next question, that is question number 17. 17 is show that the points A, B, C show that the points A, comma B and C with position vectors A is equal to 3i minus 4j minus 4k, comma B is equal to 2i minus j plus k, and C is equal to I minus 3j minus 5k respectively. Form the vertices of right angled triangle. Vertices of a right angled triangle. Show that the points A, B, C with position vectors. Here directly they have given you these are the position vectors. That means vector joined from origin to the point A, from origin to point B, from origin to point C. Directly they are saying it. And they have mentioned those position vectors as A, B, C also. Form the vertices of a right angled triangle. Okay, now here what is vector OA? Here vector OA is named as vector A, that is 3i minus 4j minus 4k. Next, what about the vector OB? Vector OB is position vector of the point B, that is named as vector B. This is equal to 2i minus j plus k. And then vector OC is position vector of point C, that is I minus 3j minus 5k. Form the vertices of a right angled triangle. So right angled triangle, we need lengths of sides of triangle here to use Pythagoras theorem. Hence let us find out vectors of sides of the triangle. What are the sides there? Sides are AB, BC and C. What will be the vector AB? Vector AB is a line segment joining the points A and B, where A is first point, B is a second point. Vector AB is equal to vector OB minus vector OA. Okay. Vector OB is directly given to us. Write it. 2i minus j plus k minus of vector OA is 3i minus 4j minus 4k. Then vector AB is equal to 2i minus 3i is minus I, minus j plus 4j is plus 3j, plus k plus 5k is plus plus 4k, plus k plus 4k is plus 5k. What is this? This is vector AB is equal to, what I want? I want length of this vector. So let us take the magnitude. Magnitude of vector AB is equal to, this is square root of minus 1 square plus 3 square plus 5 square. This is square root of 1 plus 9 plus 25. 1 plus 9 plus 25 is square root of 35. What is this? This is length of vector AB is equal to. To use Pythagoras theorem, we want square of that length. So what you do? Square on both sides. Squaring on both sides, we have this length as 35. Okay. Next, AB length we found. Now let us find out BC. BC is what? BC is a line joining 2 points B and C. So BC will be OC minus OB. What is OC? OC is I minus 3j minus 5k minus of OB is 2I minus j plus k. Yes, subtract the corresponding components. I minus 2 is minus I, minus 3 minus minus it is plus, means minus 2j, minus 5 minus in the sense it is minus 6k. What is this? This is vector BC is equal to. So magnitude of vector BC is square root of minus 1 square plus minus 2 square plus minus 6 square. This is square root of 1 plus 4 plus 36. 1 plus 4 plus 36 is square root of 41. Then square of this length BC square is equal to 41. Now let us find out the third side AC. Vector AC is equal to vector OC minus vector OA. Let us substitute vector OC first. OC is I minus 3j minus 5k. Here you can, even if you take C also no problem, that will be correct only. Minus of OA is 3I minus 4j minus 4k. Then subtracting the corresponding components, I minus 3I is minus 2I, minus 3j plus 4j is plus j, minus 5k plus 4k is minus k. What is this? This is vector AC is equal to. Then what about its magnitude? Magnitude of vector AC is equal to square root of minus 2 square plus 1 square plus minus 1 square. So we have magnitude of vector AC is equal to square root of 4 plus 1 plus 1, that is square root of 6. Then if you square, magnitude of AC square is equal to 6. Now sum of squares of two sides, will it be equal to the hypotenuse? Let us check it. Let us take the sum of AB square and AC square. AB square plus AC square is equal to 35 plus 6, that is nothing but 41, means this is BC square. So AB square plus AC square is equal to BC square. What does it indicate? It indicates that three given points are forming a right angled triangle with the right angle at which vertex? Here BC square is there, in the sense right angle will be at the vertex A. Okay. Now here we will write, therefore the given points A, B and C with position vectors are forming a right angled triangle, Okay, this is about question number 17. Now let us take question number 18. Question number 18 is, in the triangle ABC, which of the following is not true? There is a triangle given to us, A, B, C, these are the vertices. in triangle ABC, in triangle ABC, which of the following is not true? Which of the following is not true? Option A, vector AB plus vector BC plus vector CA is equal to null vector. Vector B, vector AB plus vector BC minus vector AC is equal to null vector. Vector C, vector AB plus vector BC minus vector CA is equal to null vector. D, vector AB minus vector CB plus vector CA is equal to null vector. See, very simple concept it is. I hope all of you know the triangle law of vector addition. What triangle law of vector addition says? Sum of two vectors AB and BC, I can take the sum of these two. AB is the first vector, BC is second vector. Terminal point of first vector is getting coincide with initial point of next vector. So I can write vector AB plus vector BC, which is equal to vector AC. How is this? This is according to the triangle law of vector addition. Or you can go like I told you one thing, that is sides of a triangle taken in a particular order leads to null vector. AB, BC, if you come back CA, that will be null vector only. Now let me rewrite it. Vector AB plus vector BC is equal to, here is vector AC. I will write negative of this vector. What is negative of a vector? Negative of a vector is a vector having the same magnitude but opposite direction, that is negative. So here negative of that will be minus AC. AC if you interchange again, that will be CA. So minus CA is same as AC. CA change in direction, again minus has got multiplied, you know, again one more time change in direction means same as AC only. Let us take it back, let us take it to the left hand side. AB plus BC plus CA is equal to null vector. With its with this single statement they are answering all the questions here. See, which of the following is not true? Here three options are true ones, only one is wrong, it is not true, that one we need to find out. Vector AB plus vector BC plus vector CA is equal to null vector, okay, that is correct only, that is correct. And now we should not take that, because our question is to identify which is not true. Fine. Now what about the second one? AB plus BC, first two things they have kept as it is. Then CA, CA is nothing but what? CA is nothing but a minus AC. You see, CA is there, minus AC, one time minus is there and AC, direction both time it is changed, you know, again it will be same as the original one. So CA is same as minus AC, that means B option is also correct only, B option is not wrong. Now coming to the C, AB plus BC they kept as it is, AB plus BC they kept as it is, and then minus CA is given to us. It is actually plus CA, it is actually plus CA, but it is given as minus CA in this. So option C, this is wrong. Which option I have to tick? I have to tick option C here. This is wrong. What about the option D? Shall we check it whether it is correct or not? AB minus CB plus CA. See, our statement is AB plus BC plus CA. BC they have written as minus CB. Minus CB is the same as plus BC. Both are same only. So D is also correct one only. Not true means C is not true. I will take the last question in the exercise 10.2, question number 19. Question number 19 is, if A and B are, if vector A and vector B are two collinear vectors, then which of the following are incorrect? Then which of the following are incorrect? Option A, vector B is equal to lambda times vector A for some scalar lambda. Next, B, vector A is equal to plus or minus vector B. C, the respective components of A and B are not proportional D, both the vectors A and B have same direction but different magnitudes. I hope you know the concept of collinear vectors. A and B are two collinear vectors. You have to be careful. What do you mean by collinear vectors? Two vectors having the same line of support irrespective of their magnitude and direction are called as collinear vectors. Means parallel vectors. What about the direction? Direction can be anything, and magnitude can be anything. They have to be parallel. That means both should have same line of support. In that case, we call those as collinear vectors. How to identify the given two vectors are collinear or not? Two ways I told you. One vector, if it can be expressed as some real number times the another one vector, then we say the vectors are collinear vectors. What about this lambda value can be? Lambda value can be any real number. One vector is equal to some real number times another one vector. If it is possible to express like this, then vector A and vector B are collinear vectors. That is the concept we know. And then if it is given in the component form, then what it is? I told you, if there is vector A is equal to a1i plus b1j plus c1k and vector B is equal to a2i plus b2j plus c2k, corresponding components ratios are same, means then the vectors are collinear. That means corresponding components ratios, here a1 by a2, this should be equal to b1 by b2, this should be equal to c1 by c2. All these ratios have a same value. Then we say those two vectors A and B are collinear. So let us check all the options given here. What is the question here? Which of the following are incorrect? Which of the following are incorrect is our question here. Now option A, B is equal to lambda times A for some scalar value. Scalar means any real value. Yes, that option is correct. Which is incorrect, that one we have to take. It is correct only. Now correct. No need to take A. Coming to the option B, A is equal to plus or minus B. Plus means it is plus 1 or minus means it is minus 1. A is equal to 1 times B. Yes, this can be there. 1 is a scalar value. A is equal to minus 1 times B can be there. Yes, that is also correct only. B is a correct one. B is a correct one. Next, third one. The respective components of A and B are not proportional. See what they are saying. Already what the concept we know. If corresponding components of two vectors are proportional, then they are collinear. Here what they are saying, not proportional. Means this option is incorrect. This option is incorrect. Now coming to the option D. Both the vectors A and B have same direction but different magnitudes. What is the definition of collinear vectors? Vectors having the same line of support irrespective of their magnitude and direction. Here what they are saying? They are saying same direction. Directions can be deadly opposite. Direction doesn't matter here. They are saying same direction. So option D is also incorrect. Option D is also incorrect. What are the options I can tick here? I can tick both C and D. Both C and D are the correct options for the answer. But as it is a multiple choice, only one should be correct one. We will not deal with the multiple choice correct questions. Means multiple answers correct questions. Like that we will not deal. But here what we do, textbook gives us option D. Hence we will correct this question. This question there is a small misprint. We will cancel this not word in this. We will cancel this not word. Then C will be the respective components of A and B are proportional. Respective components of A and B are proportional means that is correct one. Respective components are proportional. But D, they are saying same direction, that is wrong. Only incorrect question means only incorrect option is D. So we need to take D here. If you didn't cancel this not in the option, then both are correct only. In some of the textbooks it is omitted. They have removed this not word. That's why I am saying remove that not word, then take option D. With this exercise 10.2 complete. Thank you.